what we're going to do today then is we're going to just pick up at the end of where we left off, and we're going to take a slight detour and then come back to where we were. But before we do that, just to recap, we had spoken about chapter 27, which was basically looking at short-run equilibrium in the Keynesian cross diagram, where we just assume that prices are fixed. So without worrying about any kind of change in prices, how do we get equilibrium in our economy? Well, equilibrium in terms of our Keynesian cross diagram looks like this. There we go. We have our aggregate expenditure as a function, so aggregate expenditure as a function of real GDP also being equal to income. So aggregate expenditure as a function of income or real GDP, it's upward sloping, and at some point our level of aggregate expenditure must equal our level of income, and that point is given by the 45-degree line, obviously, because the 45-degree line gives us all the points of equilibrium between real GDP and aggregate expenditure. So where our aggregate expenditure curve intersects the 45-degree line, at that point we know that our level of expenditure equals our level of output or our level of income. In other words, everything we are planning to produce, we are in fact consuming and selling in some way. So without worrying about any kind of change in prices, what happens if we are not at equilibrium is that we have a change in output through things like inventory adjustments. So there was a multiplier effect that we looked at, and that was pretty much everything in this chapter. We did at the end of the discussion, however, talk about what happens when you have a change in price level in this model. When you have a change in the price level, we saw that we shift the aggregate expenditure curve either up or down. If our price level increases, then our aggregate expenditure curve would shift downwards. If our price level decreased, then our aggregate expenditure curve would shift upwards. And we saw that there was the way that we can explain that. One of the ways in which we can explain it is through something like the wealth effect. So if you recall, autonomous expenditure, little a, autonomous consumption, is dependent on, or one of the things that determines the level of A is your level of real wealth. If the price level changes, then your real wealth changes, and that affects your level of autonomous consumption expenditure. And that was the end of chapter 27. We then went back to chapter 25, because we had skipped it initially, just to give Yanni a chance to come and chat to us. We then went back to chapter 25. We spoke about money, and ultimately we developed a model of the money market. And the model of the money market looks like this. So we have a money supply curve and a money demand curve. In the chapter, the money supply curve is upward sloping. Usually, however, when we work with the money market, we normally just deal with a perfectly vertical money supply curve. And we saw that there's the distinction between an upward sloping money supply curve and a vertical money supply curve just has to do with how much control you think the banking sector has on money supply. If you have a perfectly vertical money supply curve, then the money supply is entirely controlled by the Reserve Bank. If we assume that the money supply curve is upward sloping, then we're assuming that the banking system has some influence on our money supply as well. The easiest way to deal with this model, though, is just to have a vertical money supply curve, so that's usually the way we deal with it. At the end of our discussion on the money market, we came to this statement here: what happens in the long run, talking about monetary policy, when we're talking about equilibrium, the effects of monetary policy on equilibrium, and then obviously the long run effects on equilibrium. So we had this statement here which I noted was quite complicated, and I said we would use this statement essentially as a springboard to the next chapters where we're talking about ASAD. So this statement said, when the inflation rate equals the expected inflation rate, and when real GDP equals potential GDP, the money market, the loanable funds market, the goods market, the labor market, they're all in long run equilibrium. The economy is in long run equilibrium. I said, as a statement in itself, that's not very self-explanatory, and in fact, we're going to see what that means as a diagram when we deal with our ASAD model. So we'll come back to the statements once we've dealt more with the ASAD model. But before we get to the ASAD model, which is where I say I want to take a slight detour, I just noticed in the handbook that in our actual course calendar here, it says the ISLM model is what we're also supposed to be doing. In other words, it says Appendix to Chapter 27. Okay? So we hadn't done the ISLM model. There are no slides, though, for that. I actually just want to double check something quickly. And in fact, in the appendix, you will notice that there is no ISLM model. That's right. So in this version of the textbook, in the appendix to Chapter 27, there is no ISLM model. So what you should have, as pointed out, what you should have is this PDF document, which is the appendix to Chapter 27 with the ISLM model. Has anyone not got this, or anyone not aware of this thing? Has everyone got it? You all know what this is. Okay. I also just put it on Sakai under my folder. You know, on Sakai there's that little folder, Nick, yeah? And under my folder there's 4 other folders. There's the folder for all the course notes that we do. There's the folder for all the slides with the notes that I make on the slides. There's the folder for all the videos, and then there's another folder which says other notes. So I just put this PDF under other notes as well. So if for whatever reason you've lost it in your email, or you can't track it down, or you don't have it, then just go to that folder and you'll be able to get it there. So this is the appendix to the ISLM model. It's not very long. It's just, what does it say here? 7 pages. It's a 7-page appendix. It doesn't have slides. However, I do happen to have slides from an older version of this textbook when it was something called the Appendix to Chapter 29, ISLM model of the aggregate demand. So these slides will also then be under my folder on Sakai. Okay? So you can go get it there. So what we're going to do is we're going to just quickly do the ISLM model before we move to ASAD. Now the ISLM model also assumes that prices are fixed. So really it's a natural extension. Having dealt with the aggregate expenditure model, the Keynesian cross aggregate expenditure model, and having dealt with the money market, both of those where prices are fixed, ISLM is the natural extension because it combines both of those still when prices are fixed. We'll see what happens if we adjust prices in the ISLM model. What we'll eventually end up with is the same kind of situation that we had when we adjusted prices in the aggregate expenditure model. The same situation as when we adjusted prices in the money model. You'll see that the effects are the same in this ISLM. But when we first derive it, we're just going to derive it without worrying about prices. So prices are fixed for this point in time. So what is our ISLM model? What are we doing here? Explain the purpose and the origin of the ISLM model. Okay, we're going to derive it. We're going to first derive IS, then we're going to derive LM, and then we're going to put them together to form the ISLM. The importance of this model will be using it to analyze the effects of fiscal and monetary policy. That was what it was originally essentially put together for. What was its purpose? Looking at fiscal and monetary policy stuff. What happens when we use this model, what happens when we use this model to understand the effects of price changes is that we can use it to then derive aggregate demand. So that's our roadmap for today. Any questions or any issues anyone wants to raise? Okay, let's jump into it then. Why do we have the ISLM model? As I said, it provides a tool for analyzing fiscal policy and monetary policy. Ultimately, we can then use it to derive aggregate demand. The ISLM model shows how real GDP and interest rates are determined simultaneously by equilibrium expenditure and money market equilibrium. In other words, equilibrium in the AE model and the aggregate expenditure model, and equilibrium in our money market. Okay? We bring those two together. By doing so, we are bringing together real GDP and interest rates. We've seen that interest rates influence the aggregate expenditure model. We've seen that interest rates are determined within the money market. That means there must be some relationship between the money market and the aggregate expenditure model. That's what our ISLM diagram or ISLM model helps us to nail down. Initially invented by John Hicks, we begin with the IS curve. IS curve shows the combinations of real GDP and interest rate at which aggregate planned expenditure equals real GDP. In other words, if we've got our aggregate expenditure diagram, so we're plotting aggregate expenditure against income or output, there's a point of equilibrium. When we change the interest rate, that point of equilibrium also changes, right? If our interest rate, for example, goes down, if we assume the interest rate goes down, what happens to our aggregate expenditure curve? Our aggregate expenditure curve shifts upwards. Okay, so if our interest rates go down, our aggregate expenditure curve shifts upwards. What that would mean is essentially we have a different point of equilibrium. If this was our initial point of equilibrium, we've now got a new point of equilibrium. And what is important about our points of equilibrium, sorry, it's difficult there, is that with lower interest rates, we have higher levels of output. Okay? So it shows us the combinations of output and interest rate at which aggregate planned expenditure is in equilibrium. This model is in equilibrium. Okay? Let me see if I can just get rid of this thing to not confuse the issue. So how do we derive the IS curve? First, let's just look at a table with some figures in it, and then we'll move those tables into a diagram. So we'll plot the figures from the table. So each row is an aggregate expenditure schedule. In other words, a point on our aggregate expenditure curve. So what we've got here is autonomous expenditure is 300 at some interest rate, 6%. As the interest rate goes down, our autonomous expenditure, for example, what is a component of autonomous expenditure? Say investment is. If interest rates go down, what is investment going to do? So interest rates go down, what does investment do? Goes up. So what happens to our autonomous expenditure? Goes up, right? So as our interest rate goes down, our aggregate expenditure curve is shifting upwards because autonomous expenditure is increasing, which means that our aggregate planned expenditure, our equilibrium level, as the interest rate goes down, our equilibrium level is going up. Okay? As the interest rate goes down, aggregate planned expenditure is going up, and our equilibrium level of aggregate planned expenditure is going up. What does this look like as a diagram? Sorry, here we go. In part A, the aggregate expenditure curve AEA corresponds to the first row of that table. Okay, so here's A. Autonomous expenditure is 300. So we're saying that we've got some level of expenditure, 300. Okay, our aggregate planned expenditure at equilibrium is 1,100. Here's our equilibrium level, 1,100. Okay. As the interest rate falls to 5%, aggregate expenditure shifts upwards from AE0 to AEB. Okay? So we now move to point B. As the interest rate decreases, autonomous aggregate expenditure increases. In other words, our aggregate expenditure curve shifts upwards and our equilibrium value increases. So here's our aggregate expenditure curve. It shifts upwards and our equilibrium value increases from point A to point B. Equilibrium expenditure is now at point B and real GDP is 1,300. If we now want to understand the relationship between the interest rate at point A, which was 6%, and our equilibrium, at 6%, our equilibrium value of real GDP was 1,100. When our interest rate decreases, what happens? Our interest rate decreases and our equilibrium level of output increases. We move from a point A representing the equilibrium level of GDP at interest rate 6% to point B, which is now our equilibrium level of real GDP at a lower interest rate. And we can continue this process. What happens if we drop our interest rate lower from 5 to 4? Our aggregate expenditure curve is going to do what? It's going to shift up some more. As it shifts up more, what's going to happen to our equilibrium level of output? Well, we shift our curve up. Our equilibrium level of output increases once again. Right? Now, if we join points A, B, and C, we end up with a downward sloping relationship. In other words, the relationship between output and interest rate, when we're looking at aggregate expenditure, in other words, this is a demand side, this is expenditure, okay? The relationship between spending and interest rates is negative. Right? Are we together on that? IS stands for investment equal to savings. That's what the IS curve stands for. So remember, at each of these points, the level of investment equals the level of savings. Remember, at equilibrium, planned investment equals savings. Right? Everyone happy with that? I'm getting no response. What does that mean? You are happy with it? Okay. So these are all points of equilibrium in our aggregate expenditure model, which means these are all points at which investment equals savings. So the IS curve is plotting all the different points in which investment equals savings. All those points, when plotted together, give us a negative relationship between the interest rate and real GDP. As the interest rate goes down, our level of output increases when we're dealing with expenditure. And that's our IS curve. And there's nothing more complicated than that for deriving the IS curve. We can then derive the LM curve. Well, first, before we just go to that slide, are there any questions? Any issues? Anything you want clarification on? Okay. So then, the LM curve. What is the LM curve all about? it shows us the combinations of real GDP, combinations of real GDP and interest rate again, except that now we're looking at equilibrium in the money market. In other words, the point at which the quantity of real money demanded equals the quantity of real money supplied. So we're talking about equilibrium in the money market. Right? So we're going to see how we derive the LM curve from equilibrium in the money market, but the first thing that we're going to do is look at some figures and then we'll plot them. So in our money market, what we're saying is the following. At any particular interest rate, there is a quantity of real money demanded. And remember, the quantity of real money demanded is a function of GDP. In other words, at a real GDP, as the interest rate falls, the quantity of money demanded increases. Why is that the case? At some interest rate, the quantity of real money demanded is going to be purchasing some level of output, right? In other words, real money demanded for purchases. Okay, that is what we use the money for. If the interest rate is going down, remember from our money market discussion, if the interest rate goes down, why does the quantity of money demanded go up? In other words, so let me plot it with a vertical money supply curve, right? If our money supply remains the same, if the interest rate goes down, we would be moving down a money demand curve, correct? But if our money supply is remaining unchanged, if we move from our initial point of equilibrium, call it point A, oh my goodness, down to this second point B on our money demand curve. So I'm moving from this is my point A, here's my point B. The problem with point B is it's not a point of equilibrium. Okay? Our point of equilibrium would be at point C. What they're saying is, in fact, as the interest rate goes down, obviously we're comparing 1400 to 1460, right? So as the interest rate goes down, the quantity of money demanded would increase. Okay? In other words, we'd be moving from point A to point B, right? As the interest rate goes down, we move from point A to point B. The quantity of money demanded would increase if interest rates fell, right? However, point B is not a point of equilibrium, right? If our money supply does not change, for equilibrium to be restored, the only way that equilibrium could be restored would be if our money demand curve actually shifted to the left. And remember, money demand is a function of output. So for our money demand to shift to the left, what would have to happen to output? It would decrease. If output decreases, money demand shifts to the left, and that would restore equilibrium if our money supply remained unchanged. Okay? In other words, even though the money demand relationship is negative, which is to say, as interest rates decrease, the quantity of money demanded increases. The relationship in the money market between real output and interest rate is the reverse, the inverse, right? In other words, interest rates go down in the money market, quantity of money demanded goes up. But interest rates going down and equilibrium in the money market would be interest rates going down and level of output going down. In other words, for lower interest rates in some given money supply, because we're talking about the relationship between output and interest rates, right? We're not interested in our money supply has no relationship to output. The only thing that has any relationship to output in the money market is the money demand curve. Okay? As output decreases, money demand shifts to the left. Are we happy with that idea? As money demand shifts to the left, equilibrium in our money market will be at lower and lower interest rates. Let me draw this in a bigger diagram because I'm giving you a lot of information and just not drawing it. Okay, so if we've got a money supply, we've got some level of money demand, MD, 0. Money demand is linked to real money demanded for purchases, right? In other words, real money, we use it for some level of output. That's what we need money demand for, buying stuff. Okay? If our level of output decreases, so if we have Y decreases, okay? So that we have Y0 greater than Y1. In other words, we're decreasing output, moving from Y0 to some lower level of output, Y1. If we have a lower level of output, what does that mean about the money, the quantity of, or just the amount of money that we demand? Real money demanded for purchases. If output is lower, what does that mean about the real amount of money that we require? It's going to be lower. Okay? In other words, our money demand curve at any given interest rate. So, at any given interest rate, we require some level of money to purchase output. If we do not change the interest rate, so the interest rate remains I0, we don't change the interest rate, but we change the level of output to Y1. That means at that same level of interest rates, we don't require the same quantity of money. We now only require less money, right? Which means at the same interest rate, let's shift our money demand curve to here, MD1 at Y1. At the same interest rate, we now demand a smaller quantity of money. Is everyone with me? Okay? So when we have lower levels of output, we shift our money demand curve to the left. Okay, so let's just write that out. Lower output shifts money demand to the left. Everyone with me? Yeah? At MD0, so at our first money demand curve, when we had some level of output Y0, we had some level of equilibrium. We're at point A, that's our equilibrium point. So we're at point A, and at point A, goodness, we have some level of interest rate, let's call it interest rate A, and we have some level of money demanded, QMA, right? At point A, we have interest rates A and money demanded QMA. What happens when the level of output changes? So we move from MD0 to MD1, and our level of output changes. Well, then we move from an equilibrium position A to a new equilibrium position B. At our new equilibrium position B, we have a different interest rate, IB, although we still have the same quantity of money because we have not changed our money supply curve. So at point B, what do we end up with? Interest rates B and QM unchanged. And what do we know about the relationship between interest rate B and interest rate A? Interest rate B is less than interest rate A. Are we happy with that? So what do we see is the relationship when output is at level Y0, we have interest rate IA. When output is at when output is at level Y1, we have interest rate IB. When output decreases, what happens to interest rates? It decreases. Are you happy with that idea? Okay. Conversely, obviously, when output increases, what's going to happen to my interest rate? It's going to increase. So what then is the relationship between output and interest rates in the money market? Is it a positive relationship or a negative relationship? It's a positive relationship. In other words, if I were to plot the interest rate against the level of output, what should my relationship be? Upward sloping. That's a positive relationship. You with me? And we call this the Lm curve. And what Lm stands for is liquidity equal to money. Okay? Liquidity, I'll get to you in a sec. Liquidity means money demand. In other words, liquidity is money that we want to use for purchases. That's what liquid is for. That's what liquid means. Something that can be used as soon as we want it, right? So money demand is a demand for liquidity, and then liquidity equal to money, and money here meaning money supply. So this is all the points of equilibrium between our demand for money, liquidity, our demand for liquidity, and the supply of money, Lm, okay? So all the different points of equilibrium in our money market for different levels of output, different interest rates, the relationship is positive. It's an Lm curve. So now, going back to our table, but first dealing with your question. Yes?
Can we go back to that?
Yes.
Why did the quantity of money remain unchanged?
Just because we had not shifted our money supply curve, and I just assumed a vertical money supply curve. If we'd had an upward sloping money supply curve, then the quantity would have changed. But as I say, it's always easier to deal with a vertical money supply curve, and you'll see the diagram deals with a vertical money supply curve as well. Okay, any other questions about this particular diagram? Okay, let me just then talk through the slides quickly, and then I'm going to give you, I suppose then it'll be time for a break, but after that you can do some plotting yourself. Okay, so what is happening in our Lm curve? The real GDP, as interest rate falls, the quantity of money demanded increases. Okay, so that's the relationship between interest rates and the quantity of money. However, at a given interest rate, as real GDP increases, the quantity of money increases. Okay? In other words, the reverse, if we were to go, as the real interest rate increases, real GDP increases, and the quantity of money increases. So, as real GDP increases, the quantity of money demanded increases. Okay? So here's our how we derive the relationship in a lot more detail, but with our table, what we see is as the interest rate goes down, we have lower levels of equilibrium in our money market because the quantity of money demanded is decreasing as the interest rate is decreasing. Why? Because as the level of output, decreases, so the equilibrium interest rate decreases. So remember, this is not expenditure. In other words, this relationship here that is being described is not aggregate expenditure, not an aggregate expenditure relationship. Okay? The aggregate expenditure relationship is the following. As interest rate decreases, output increases. The fact that there is a positive relationship between real GDP and interest rate is not because of an aggregate expenditure relationship, but because of a money market relationship. Okay? So, stepping through that table, we have our money supply curve at some level of output, 1,400. Oh, sorry, that's not a level of output, that's level of money, 1,400. We have some level of GDP, 1,100. So this is money demand when output equals 1,100. Okay? We have an interest rate of 4%. If we increase output, what happens to the level of money demanded? As we increase output, money demand increases. As money demand increases, what happens to our interest rate in our money market? It increases. So if we're plotting now interest rate against level of output, we see that interest rate decreases. So you move from point D to point E. Yes? Is MS always vertical in what sense? Do you mean like, apart from everything else that I said earlier? So maybe just to reiterate what I said earlier then, the money supply could be upward sloping, it could be vertical. If we take an upward sloping money supply, it just depends on how much emphasis we place on the banking system controlling the money supply. If we have a vertical money supply, we're assuming that it's entirely controlled by the Reserve Bank. It's easiest to plot everything here by just using a vertical money supply curve. Does it need to be vertical? No. It's easy to plot it when it's vertical. Is it always vertical when we plot these things? It will be, yes, in the textbook. Does it have to be? No. Does that? Okay. So we move from point D to point E. Then, again, so this was money demand level 1,100. If our output increases to 1,300, it shifts our money demand curve. And so we end up with this upward sloping relationship in our money market. Oh, I'm going the wrong way, sorry. So once again, we increase output, we shift the money demand curve. That raises interest rates in the money market, which means that our relationship between interest rates and output in the money market is upward sloping. And we call that the LM curve. We then bring the LM curve and the IS curve together. And this point of equilibrium is what? Well, first of all, are you happy that point B is on the IS curve? It lies on that IS curve. Are you with me? Are you happy that point B lies on the LM curve? Okay. If we are at point B, and because we're at point B, we are on a point on the IS curve, what does that tell us about aggregate expenditure? It tells us that we're at a point of equilibrium in our aggregate expenditure model. Yeah? In other words, we know that at every point on the IS curve, aggregate expenditure equals output. Which means at point B, we know that aggregate expenditure is equal to output. Okay? So we're not going to have inventory changes. We're not going to have unplanned inventory changes at point B. Are we happy with that? Yes? You happy with that? Do I need to repeat it? At point B, are you happy that at point B we are on the IS curve? Are you happy that all the points of the IS curve are points of equilibrium in the aggregate expenditure model? In other words, the IS curve shows us all the different points shows us all the different locations or locales or locuses where AE equals Y given different interest rates. In other words, as we change the interest rate, we shift aggregate expenditure. As we shift aggregate expenditure, either up or down, we change the equilibrium level of output. And as the interest rate goes down, the equilibrium level of output goes up. In other words, as the interest rate goes down, the aggregate expenditure curve shifts upwards, meaning that our equilibrium level of output in the aggregate expenditure curve goes, in the aggregate expenditure model goes up. Yes or no? Okay. So on the IS curve, we have a point where aggregate expenditure equals Y. Everywhere along the IS curve, AE equals Y. Are we happy with that? Everywhere on the IS curve. So if we're at point B, are you happy that AE equals Y at point B? In other words, at point B, we have equilibrium in the goods market. We have equilibrium in the aggregate expenditure model. Yeah? Okay. What about in the money market? Are you happy that all points along the LM curve are points where money demand equals money supply? All points along the LM curve are points of equilibrium in the money market, which means point B is a point of equilibrium in the money market, right? So point B is a point of equilibrium in both the aggregate expenditure model and in the money market model, which means at point B we have equilibrium in both those markets. That's pretty cool. That means if we change something in the money market, it's going to have some effect in the aggregate goods market. If we change something in our goods market, it has some effect on the money market. How is it going to affect them? Well, we can use this diagram to see how those two things will affect each other. So let's stop there. I apologize for going over a bit. We'll take a 10-minute break, and then we're going to start with this model, and we're just going to try and break it, or break you. One of those two things will happen. And hopefully just cement all these ideas nicely. Okay. Any questions? Do come down and have a chat.